Everyone, this is the continuation of our binomial theorem. Please see the first video related to binomial theorem that has been uploaded in YouTube, and this is the continuation of binomial theorem. In this lecture we will learn general term, and we will solve at least 5 to 6 problems in order to understand binomial theorem more efficiently. Now see, here general term means r plus 1th term. So t r plus 1th term is given as NCR x to the power n minus r a to the power for x plus a whole to the power n, and for x minus a whole to the power n there is only one extra term, that is minus 1 to the power r, and the rest of the things are as it is. Now see, in the binomial expansion always remember, if your binomial expansion is regarding x plus a to the power n, the rth term from the end, that means if you have a binomial expansion, then rth term from the end is your last term. So you want to find out the terms from the last term. So there is two methods. If you want to find out the term 6th term from the first, then we have to apply t r plus 1th term, that is NCR x to the power n minus r a to the power r. But if we want to find out the 6th term from the last, so from for this you have to find out n minus r plus 2th term from the beginning. That would be the rth term from the end. Rth term from the end, that is rth term from the end is equivalent to n minus r plus 2th term from the beginning. So these two things are equal. So if they ask you to find out 6th term from the end, you have to find out, let us say n is 4, so n is, let us say 8, so 8 minus 6 plus 2. You have to find out n 8 minus 6 plus 2th term from the first. You will get the same answer. So this is very important, extremely important. Now see middle term. If you observe, in x plus a whole to the power n, we have total n plus 1th terms. So if n is even, n by 2 plus 1th term is the middle term, and if n is odd, we have two terms, that is n plus 1 by 2th term and n plus 3 by 2th term. There will be two middle terms. Now we will solve some problems regarding binomial theorem. So let us see one problem. Find 13th term in the expansion of 9x minus 1 by 3 root x to the power 18, x not equals to 0. So see, first of all we have to make this in the formula x plus a whole to the power n. So this is our x and plus of minus 1 by 3 root x to the power 18. Just now we have seen that t r plus 1th term, that is our general term. So what would be our general term? Because here we have to find out the 13th term, that is t13. So t13 is not your general term. General term you have to make it as t r plus 1th term, right? So t r plus 1th term would be t 12 plus 1. 13 you can write it as 12 plus 1. So here r is 12, here r is 12. So now apply the formula. NCR, that is n is your 18, NCR NC12, 18C12, x to the power n minus r, that is 18 minus 12 into a to the power r, that is minus 1 by 3 root x to the power 12. Now see 18C12, keep this thing as it is. Now 9x to the power 6 and this, keep this thing as it is. Now we know that NCR equals to NC n minus r. So we can write 18C12 as 18 minus 12, that is 6, 18C6, and this is 9 to the power 6 into x to the power 6, and this would be 3 to the power 12, 1 by 3 to the power 12, and this would be x to the power half to the power multiplied by 12, that is x to the power 6, and minus 1 to the power 12 is plus 1. So x to the power 6, x to the power gets cancelled out. This is 3 square, that is 3 to the power 12. So this thing also gone. So only one thing we have left out with 18C6. Now apply the formula, n factorial divided by r factorial into n minus r factorial, 18 minus 6 factorial. Now break the terms. If you can break, you can break it something like this: 18, 17, 16, 15, 14, 13 and 12 factorial, because we have 12 factorial maximum in the denominator. So 12 factorial and 6 factorial, you can write it as 6, 5, 4, 3, 2, 1. So this 12 factorial gets cancelled out. Now cancel other terms and simplify, you will get 18,564 as the answer. Now let us see next question. Find n if the ratio of the fifth term from the beginning to the fifth term from the end in the expansion of fourth root of 2 plus 1 by 4th root of 3 to the power n is root 6 is to 1. That is fifth term from beginning and fifth term from end. This ratio is given as root 6 is to 1. So let us see what is the fifth term from the end, that is n minus r plus 12th term from the beginning. In the last slide we have seen. So n minus r plus 12th term from the beginning. Now r is our fifth term, that is our r. So n minus 5 plus 12th term from the beginning, that is n minus 3th term from the beginning. Now what would be the t5? t5 is simply fifth term from beginning, right? t5. So we can make it as t4 plus 1. Now apply the same formula we have applied here. NCR x to the power n minus r a to the power r. NCR x to the power x to the power x to the power, that is 4th root of 2, x to the power n minus r n minus 4 and a to the power r, that is our 4. Now you have to simplify. This is NCR. Now this is 2 to the power 1 by 4 multiplied by n minus 4, that is n minus 4 by 4, and this is multiplied by 3 to the power 1 by 4 multiplied by 4 cancel out, we only have 1 by 3. Now fifth term from the end is our n minus 3th term from the beginning. So t n minus 3, that is, this is our fifth term from the end. So t n minus 3 would be t n, we have to make it as t r plus 1th term. So in order to make t n minus 3 as t r plus 1th term, in decrease by 1 here and increase by 1 here. So n minus 4 plus 1, that is our r is now n minus 4. So NCR a to the power n minus r into x to the power n minus r into a to the power r. Now you have to simplify, this is n cancel out, this would be plus 4. So 2 to the power 1 by 4 into 4 will cancel out, you will get only 2. And here 3 to the power 1 by 4 multiplied by n minus 4, that is 3 to the power n minus 4 by 4. Now see, it is given that ratio is root 6 is to 1, that is t5 by t n minus 3. t n minus 3 is the fifth term from the end, that is n minus 3th term from the beginning, and we have found out that this term from the beginning, fifth term from the beginning, is that term. So t5 by t n minus 3, put those two things here. Now simplify. Now see, NCR we can write it as n factorial divided by 4 factorial into n minus 4 factorial, and here we can write it as n minus 4, we can write it as NCR n factorial divided by n minus 4 r factorial into n minus r factorial, that is n minus of n minus 4 factorial. Now cancels, this n factorial cancel out and simplify, you will get the next term as this thing, 2 to the power n minus 4 by 4 minus 1 and 3 to the power n minus 4 by 4 minus 1 equals to, this is 6 to the power half. Now simplify, you will get n equals to 10 here. So simplification is your part. I think you can solve this simplification. So we will see next problem. So let us see another problem. Show that the middle term in the expansion of 1 plus x to the power 2n is 1 is into 3 into 5, 2n minus 1, 2 to the power n, x to the power n by n factorial. See, it can be clearly seen that 1 plus x to the power 2n. So it is n is multiplied by 2, that means the term is even term, right? So 2n is even, that means we have only one middle term. So middle term is n by 2 plus 1th term. So 2n by 2 plus 1th term, that is n plus 1th term is your middle term. Now we know the general term T r plus 1th term. So here T n plus 1th term. So r is your n. R is your n. So NCR, that is 2nCn x to the power x is your 1. Here let us say x to the power n minus r, a to the power r, that is x to the power n. R is your n. Now 1 to the power something is 1. So we have 2nCn x to the power n. Now simplify, break this thing, 2nCn, that is n factorial, that is 2n factorial, by n minus r factorial, that is 2n minus n factorial, into r factorial, that is n factorial. Now 2n factorial can be resolved as 2n, 2n minus 1, 2n minus 2, 2n minus 3 up to 6, 5, 4, 3, 2, 1. Okay, from the back end we can write, from the front end we can write in this way, right? Because see, n factorial can be written as n into n minus 1 into n minus 2 up to 5, 4, 3, 2, 1, right? So we can write it as from the front end as 1, 2, 3, 4, 5. From end, at the end it will be n. So at the end it will be 2n. By 2n minus 1 is n factorial, and this is n factorial, and x to the power n. Keep the thing as it is. From this term we can separate the odd term and even term. So odd terms will be 1, 3, 5, 2n minus 3, then 2n minus 1 would be odd terms, and even terms would be 2, 4, 6, 2n minus 2 and 2n would be even terms. We have separated the even terms and odd terms from this whole term, and rest of the things as it is, x to the power n by n factorial into n factorial. Now see, from even terms, if you take 2 common from every term, that is 2 from here, 2 from here, 2 from here, 2 from here, and 2 from here. So we will have 2 to the power n terms, 2 to the power n common terms in the whole term. See, if we take 2 common here, and if we take 2 common from 4, then that means for 2 terms we have 2 square terms. We have n terms, so we will have 2 to the power n, 2 common from this whole term. So if we take 2 common, we will have 1. If we take 2 from 4, we will have 2. So up to, if we take 2 from 2n, we will have n. So from that we can say that this thing n into n minus 1 up to 3 to 1 is your n factorial, right? So this whole thing can be written as n factorial, and keep the thing as it is. Now 1, 3, 5, 2n minus, this is 2n minus 1, n factorial gets cancelled out, and you will have n factorial in the denominator and 2 to the power n and x to the power n. That's all you have to prove. Now let us see another problem. So let us see another type of problem. Find the coefficient of x to the power 40 in the expansion of this thing, 1 plus 2x plus x square to the power 27. So see, x square plus 2ab plus b square, that is 1 plus x whole square to 27, that means 1 plus x to the power 54. So in this type of problem, if you can assume something like this, that let x to the power 40 occurs in r plus 1th term, that is we want to find out the general term. So T r plus 1th term would be NCR, that is 54 CR, a to the power n minus r, a to the power n minus r, a is 1, so 1 to the power something is 1, and x to the power r, x to the power r. In order to find out the coefficient of x to the power 40, that means in this general term r should be 40, so that x to the power 40. So if it is 40, then this r would be 40, then 54 C40. 54 C40 would be your coefficient of x to the power 40. Coefficient of x to the power 40. Coefficient of x to the power 40. That means whatever remains except x to the power 40 is your coefficient of x to the power 40 in the general expression of this term. Now find out the coefficient of x to the power 5 in the expansion of this thing. So here is a multiplication, so you have to break it up to certain terms in order to find out x to the power 5. So we are let's break NCR, this is 1, right? So NC0 a to the power n minus r, x to the power n minus r, a to the power r. NC1 a to the power a is 1, so one term, this will be this can be omitted 1, right? So 6C1 2x to the power 1, 62, 2x to the power 2, 63, 2x to the power cube, up to 6 term. We have 6 term. So up to 6 multiplied by this thing, multiplied by this. So here we have minus. So in odd terms we will be we would have minus. So 1 minus 7c1x plus 7c2x square minus 7c3x cube plus 7c4 dot dot dot, because we want to find out the coefficient of x to the power 5. That means, see, we have 2x here, that means we have x here. So x multiplied by something x to the power 4 would be your coefficient of x to the power 5. X square multiplied by x cube would be your coefficient of x to the power 5. X cube multiplied by x square would be your coefficient of x to the power 5. X to the power 4 multiplied by x would be your coefficient, and x to the power 5 multiplied by 1 would be your coefficient. After that we don't have to break. After x to the power 5 we don't have to break, because we need only x to the power 5. So if you simplify this thing, 61 is 6, NC1 is n, right? We have already formulated in the first lecture. So 6 NC1 is 61 is 6, 6 into 2, that is 12 x. Now 62, calculate 62, 62, 6 factorial by 2 factorial into 6 minus 2 factorial, that is 4 factorial. You can write it as 6, 5 into 4 factorial divided by 2 into 4 factorial. This 4 factorial cancel out, this 2, 3, 3 5 are 15. 15 multiplied by we have 2 here, 15. Let us see it again. 6 factorial by 2 factorial into 6 minus 2, that is 4 factorial. 6, 5, 4, 4 gets cancelled out. 2, 3, 15. Okay, 15. And in the third term we have 2 square. Okay, 15 multiplied by 4, that is 60. Okay, in this similar manner you have to break all these C component. Okay, combination components. So 7c1, nc1 is n always. So 7c1 is 7. Now after that simplify the formulas, apply these general methods, and you have to calculate. Now see, we need x to the power 5 component. So x to the power 5, that means this thing. Notice this thing, 1 multiplied by minus 21 x to the power 5. So x to the power 5 would be your the coefficient of x to the power 5 would be 1 into minus 21, right? Then 12x, x multiplied by x to the power 4. That means x into x to the power 4 is x to the power 5. That means we remains 12 into plus 12 into 35. Again x square multiplied by x cube would be x to the power 5. Then coefficient would be 60 into minus 35. X cube multiplied by x square, that is 160 into 21, and that's all. X to the power 4. That's x to the power 4 multiplied by x, that is x to the power 5, that is plus 240 into minus 7. Next term, and next term would be x to the power 5 multiplied by 1, that is 192 into 1. So add all the terms, you will get 171 as the answer. Now you will see next type of problem. So let us see another problem. Find the greatest value of the term independent of x in the expansion of x sin alpha plus cos alpha by x to the power 10, where x belongs to real number. So in this type of problem, always find out the TR plus 1th term. So TR plus 1th term would be NCR x to the power n minus r, a to the power r. So let us say this is x term, this is a term. So 10CR x to the power, this will be x to the power 10 minus r into sin alpha to the power 10 minus r, and this would be cos alpha to the power r, and this would be x to the power r. So x to the power minus r. So here we have x to the power 10 minus r, x to the power 10 minus r divided by x to the power r. So that means it would be x to the power 10 minus 2r. This is your term, x to the power 10 minus 2r. In order to be independent, see in this term, if this term has to be independent of x, that means r should be 5. Why? Because 10 minus 10 is 0, x to the power 0 is 1. So if r equals to 5, then this whole term, if this general term is independent of x, that means the whole series would be independent of x for r equals to 5, remember. So if r equals to 5, put r equals to 5 here. So t 5 plus 1, that is t 6th term. Again NCR, you have to make it as t 5 plus 1, right? So 10 c 5 NCR a to the power n minus r, a to the power, see from this and this, if this term is gone, so we will have 10 c 5 r equals to 5 here, right? R equals to 5, 10 c 5 sin alpha to the power 10 minus 5, that is sin alpha to the power 5, and cos alpha to the power 5, you can make it as sin alpha cos alpha to the power 5. What you have to do, you have to multiply it by 2 here, divide by 2 here. So 2 sin alpha cos alpha is sin 2 alpha, so sin 2 alpha to the power 5, and this is 2 to the power 5, so in the upper side it will be 2 to the power minus 5. In order to be greatest, they want the greatest term which is independent of x. So in order to be greatest, sin alpha should be pi by 2, right? So that means 2 alpha should be pi by 2. 2 alpha should be pi by 2. So the greatest term would be 10c5, or we can say sin 2 alpha should be 1. In order to be greatest, sin alpha should be 1. That means 2 alpha should be pi by 2 in order to be greatest. So greatest value would be 10c5 2 to the power minus 5. Simplify, you will get that answer. Now remember some notable things, that is coefficient of r plus 1th term in the binomial expansion of 1 plus x to the power n is NCR. Coefficient of x to the power r in the expansion of 1 plus x to the power n is NCR, same thing. Coefficient of x to the power r in the expansion of 1 minus x to the power n minus n is minus 1 to the power r, NCR. And coefficient of r plus 1th term in the expansion of 1 minus x to the power n is same term, minus 1 to the power r, NCR. Remember this. Now we will solve one problem regarding this note. So let us see another problem. Find the coefficient of x to the power 50 in the expansion of 1 plus x to the power 1000 plus x into 1 plus x to the power 999, and it is going like this, x to the power 1000. See, clearly it can be seen that it is a GP series with common ratio. Common ratio is next term by first term. So x into 1 plus x to the power 999 by 1 plus x to the power 1000 would be your x by 1 plus x, right? And if you divide x square into 1 plus x to the power 998 by x into 1 plus x to the power 999, you will get the same term. So it is our common ratio. And here total number of terms is, see here total number of terms is 1001. We starting with, because we know that in 1 plus x to the power 1000 there is n plus 1 terms. So total number of terms is 1001, and our first term is 1 plus x to the power 1000. So we will apply the sum formula for this GP series. Sum formula is a into, sum formula is Sn is a into r to the power n minus 1 by r minus 1 if r is greater than 1. Or if r is less than 1, then we will apply a into 1 minus r to the power n by 1 minus r. If you take minus 1 minus common from this, you will get the same result. So you don't have to worry about this two result. You can remember one result. So a is your first term is your 1 plus x to the power 1000, a into 1 minus r to the power n, x by 1 plus x. See, if x is something let us say 2. So 2 by 1 plus 2, that is 2 by 3. So 2 by 3 will be always less than 1. That's why we have applied 1 minus r to the power n by 1 minus r formula. Otherwise you can apply this formula also, you will get the same result. So 1 minus r, that this is your common ratio r, 1 minus r to the power n by 1 minus r. Now simplify, 1 plus x to the power 1000, this will be 1 plus x to the power 1000 minus x to the power 1001 by 1 plus x to the power 1000. This will be 1 plus x minus x will be cancelled out, you will get 1 by 1 plus x. 1 by 1 plus x will be in the upper side. So let us simplify this. If you take LCM here, you will get 1 plus x to the power 1001 minus x to the power 1001 divided by 1 plus x to the power 1001 multiplied by, from here you will get 1 plus x minus x, x will cancel out, you will get in the denominator 1 plus x, it will be in the upper side 1 plus x. Now 1 plus x, and here 1 plus x to the power 1000, 1 plus x will be cancelled out, you will get 1 plus x to the power 1000 here. So after dividing by 1 plus x to the power 1000, you will get 1 plus x to the power 1000, 1 plus x to the power 1000 will get cancelled out, you will get 1 plus x to the power 1001 minus x to the power 1001. Now see, the coefficient of x to the power 50 in the expansion of this whole thing means a coefficient of x to the power 50 in the expansion of this thing, and here it is, we can apply binomial theorem here. So from that we will find x to the power 1000, that means all the coefficient of x. So we have to find out the x to the power 50 terms. So x to the power 50 lies in this binomial expansion, right? This will cancel out. So coefficient of x to the power 50 means actually 1 plus x to the power coefficient of 50 x to the power 50 in the expansion of 1 plus x to the power 1001. Now in the notable part, I have just shown you that coefficient of x to the power r in 1 plus x to the power n is NCR. So here n is 1001 and r is 50. So 1001 C50 would be your answer. See another type of problem. So let us see another problem. Find the number of integral terms in the expansion of 5 to the power 1 by 2 plus 7 to the power 1 by 8 to the power 1024. Now see, for this type of problem you have to find out the first the general term TR plus 1 term. So n is 1024, so NCR a to the power n minus r x to the power r, x to the power n minus r a to the power r. So 1024 CR, and this will be, if you divide by 2 it will be 512 minus r by 2, and this is 7 to the power r by 8. Now if you take 5 to the power r by 2 common from this thing, see here base is same, here base is same. If you multiply you will get 512 minus r plus r by 2. So minus r plus r by 2 is actually minus r by 2. So that means you can take common 5 to the power r by 2 from this thing, and here it is 7 to the power r by 8. So it will be, keep this thing as it is, and you can take r to the power 8 power common from this. If you multiply it by 4 here, you see r by 2, you will get 5 to the power r by 2, and this will be 7 to the power r by 8. In order to make this whole thing integral, that means your this r by 8 term should be integer. So if r by 8, in order to make r by 8 integer, r should be a multiple of 8. So our term, it can be 0 also, right? It can be 0. If this term is 0, then also this would be integer. So start from 0, 8, 16, 24 and up to 1024. Now take 8 common from this. If you take 8 common from this, except 0, if you take 8 common from this, you will get 1, 2, next 3, then you will get 128. If you divide by 8 here, you will get 128. So that means we have 128 terms in this, and plus 1 term for 0. So that means we will have total 129 integral values for this term. So we have completed all the topics, all the various types of problem that may come in your exam in binomial expansion. I hope you are liking it. Please like, share, subscribe. All the best.